notes, but I couldn't.
Yeah, I forgot to upload it. I'm sorry. I will do it as soon as I'm done with this. If you have your ratio identity of cotangent equals what? Cosine theta over sine theta. So because of this identity, can I transform this cotangent into that? Yes, because when something's equivalent, I can substitute that value in. So sine is going to stay sine. However, this is going to become cosine theta over sine theta. And because of that, now I can do what?
You can cross out the sign.
Yes, ma'am. Okay. Joey, they need you in the counselor's office. Okay, so now I can cross out my signs, and all I'm left with is cosine theta over 1, which is just essentially cosine theta. So my answer is cosine theta. It's a puzzle that you are trying to maneuver pieces into and out to, and then be able to eliminate. So all I did was take that information about our basic 8 trig identities, and I applied it so that I can reduce this function. Okay, and the beauty of this is that if you're working in the main time you use sine, cosine, and tangent when you're talking about things that rotate. So if you're working in you're trying to be the creator of a car instead of being the person who puts the car together, this is what you would apply. Instead of making yourself have a longer problem, you want to try to condense your work down. So you may go through all these trials and everything, but after all those trials, you now can simplify those trials and say, okay, simply all I need is cosine. I don't need sine and cotangent, I just need sine because that will give me what I need in one step. And that's what the whole purpose of this simplifying and manipulating is. All right, on 2. 2 is sine squared cosine theta. These are already in terms of sine and cosine, but what is it? Cosecant. Can I transform cosecant into sine or cosine?
Yes.
Which one can I transform it into?
Sine.
Sine. Because cosecant is a reciprocal of sine, right? So this is going to become sine squared theta over cosine theta times 1 over sine. Okay? So I have 2 sines in my numerator and 1 sine in my denominator. So what can happen?
You can cross it out.
I can eliminate one of them. I can't cross it out, but I can eliminate. So, because it's squared. So I only can eliminate one of them, and I'm left with sine theta over cosine theta. And what is that equivalent to?
That equals tangent.
Tangent theta.
Isn't that a formula sine divided by cosine is tangent?
It's an identity. It's the opposite identity of cotangent. It's the reciprocal identity of the cotangent identity. So my answer is simply tan theta. Okay, again, all you're doing is substituting, manipulating, simplifying. Substituting, manipulating, simplifying. Okay, here. This problem comes down to, first off here, I have cosecant squared x. I have 2 options. I can go ahead and distribute, or I can go ahead and convert it into what?
Sine.
What kind of sign?
Cosine.
1 over sine squared, right? Because this is a reciprocal of cosine, correct? I mean, of sine. This is a reciprocal. It's not just cosine. Remember, cosecant equals 1 over sine. That's 1 cosecant. How many cosecants do I have now? 2. So this would become 1 over sine squared x. Does that make sense? Okay, remember we can manipulate the identities to fit our problem. Once I've done that, now I'm going to do what? Distribute. So when I distribute, I have 1 over sine squared x minus cosine squared x over sine squared x. Okay, this is an identity. What identity is that? It takes me back to what? Okay, so we can either go from there or we can combine them because they have what kind of denominators? common denominator. So now I have 1 minus cosine squared over sine squared x. And what is 1 minus cosine x? I'm going to use what identities here? I'm going to use my Pythagorean identities, right? Which Pythagorean identity does this match? It's the sine squared plus cosine squared equals 1. And did we not manipulate it to get something equal to this? What do we get equal to that?
Sine squared of x.
So I have sine squared of x over sine squared of x. So therefore my answer is 1.
Wait, how did you get?
All right. How did I get it? Because these have common denominators, right? Common denominator. I can combine by subtraction, right? So this became 1 minus cosine squared x over sine squared x. This is a Pythagorean identity. Because this is a Pythagorean identity, and our parent Pythagorean identity is sine squared x plus cosine squared x equals 1. Well, if I wanted to say 1 minus cosine squared x, that means I would have to subtract cosine squared x. And then what am I left with on this side? So that means that this is equivalent to sine squared x. And something divided by itself is 1. Doesn't matter what that something is, it's always going to be 1. And all I did was substitute that in so that I can find this value. So what this tells me, if someone gave me this mumbo jumbo up here, I know automatically no matter what value of angle I plug in, the answer is going to be 1. No matter if I put in cosecant squared of 1,000 degrees times 1 minus cosecant squared of 1,000 degrees, is going to always be 1. That's what this tells you. Because it's an identity, that means it's true for every single angle that you plug in for the x value. And your key thing is you have to figure out which of those basic 8 are you using. Okay? If you don't get comfortable with the basic 8, when we move on to the sum and difference identities of next week and the double angle identities of next week, that's where you're going to be using now multiple identities. It's not just 8. You're not going to have 13. Is it 13 or 14? I don't know what's on the other paper. Okay, so what you're going to do at your tables is work 4, 5, and 6, and they're due at the end of the period. I want you to try. I'm going to only allow each person to ask me one question, and that's it. You said you were going to come to tutorials after 5 o'clock yesterday. 5 o'clock, I told you I was. You told me you'd be here at 5.
Oh, yeah.
But he said he wasn't doing the phone.
But I can't.